is some algebra that you may need to review, and this algebra will help simplify the work that you're going to do as we work through some of the derivative examples. This is an example, a plus h cubed, that you could calculate out, evaluate, simplify by using FOIL. So in other words, we could take this a plus h and multiply it by itself 3 times. That's all that it means. But there is a pattern we can use, because when we get to a really messy example like this, it'll often be easier to know that we have it right without fail and without a lot of effort. Here's what the pattern would look like. We're going to start with row 3, and it's row 3 because we have the a plus h cubed. We're going to start with row 3 of Pascal's triangle. Quick review of what Pascal's triangle looks like. We start with a 1 on top, and then below it you have 2 1s. You always start and end with a 1, but in between we're going to add this 1 and 1 to get 2, and then end with a 1. 1, add the 1 and 2 to get 3, add 2 and 1 to get 3, and end with a 1. Notice that the 3's come from adding the 1 and 2 above it. I could get a 1, 4, 6, 4, 1. Again, where did the 4 come from? I added the 1 and 3. I got the 4 on the other side by adding 3 and 1, which of course those are always the same on both sides. It is symmetrical. And then I got the 6 by adding the 3 and the 3. So that's Pascal's triangle. It would be helpful to you to stop the video, hit pause, and confirm that you could create Pascal's triangle from scratch. The next step is to understand which row is row 3. It may seem that this row should be row 3, but it's not. That we're going to call row 2, because we call the top row row 0. So the actual row 3 is going to be the row that I'm highlighting in green here. This is what we're going to call row 3 of Pascal's triangle, because we call this row 0, row 1, row 2. So you'll see that I ended with row 4. So the way we describe the row numbers, the top row we describe as row 0. So the first step is to know where row 3 is. So if I were to use this, my row 3 would be 1, 3, 3, 1. That's the first step. The second step is to give each of these numbers an A and an H. Let me explain a little bit more what I mean by that. And for this part, I'm going to color code the A pink and the H orange, or the orange color here. So we're going to give them each an A. And I'm going to start this A as an A cubed, again, because our highest exponent is going to be a 3. And then I just count down 3, 2, 1, 0. Now I'll do the same thing with the H's. Give each term an H. But I'm going to have to go opposite from the 3. So you could say that we're starting at the end, and 3, 2, 1, 0, or if you start with the 0, 0, 1, 2, 3. Let me review that process one more time to make sure I've got everyone. I start with the 1, 1, 1, 1, 2, 1. What I'm going for is row 3 of Pascal's triangle. it's row 3 because this exponent that we're raising the binomial a plus h to is a 3. So I start by getting Pascal's triangle row 3, and then I'm going to put with each of these an a term, starting with an a3, and then a2, a1, a0. Now I'm going to do the same thing with the h's, except I'm going to start from the back, h3, h2, 1, and 0. And the only thing I need to do, other than simplifying, is to recognize that these are all being added. And that's it. All I have to do from here is simplify some exponents. So let me walk you through that. 1 times a cubed times h to the 0. Well, anything to the 0 power is just 1. So what I'm left with here is a cubed. 3a squared times h. Notice I'm going to drop that exponent of 1. 3ah squared. 1 times a to the 0 is 1 times 1, which is still just 1, h cubed, and that's it. So a plus h cubed, go ahead and FOIL it out, but you'll see that it's going to be equivalent to a cubed plus 3a squared h plus 3ah squared plus h cubed. Try it yourself one more time. Try it with a plus h to the 4th. What I'd recommend you do now is pause the video and see if you can do this yourself, and then resume the video to see if you got it. Well, all I've done here is applied Pascal's triangle, and I went to row 4. Here's row 0, row 1, row 2, row 3, and here's row 4. So this is row 4 of Pascal's triangle. Just to keep it nice and clean, I'm going to erase this part we no longer need. But feel free to review, go rewind or start the video over if you want to see it again. The next step is to take the a times each coefficient. I'm going to start with a3, a2. Oh, I'm sorry. It's not a 3, is it? It should be an a4 for this one. So I'm going to start with a4, a3, a2, a to the 1 is just a. I'll go ahead and write this a to the 0, but a to the 0, anything to the 0 power just equals 1. So this a to the 0 is just going to be a 1. Now, why did I start with a 4? Because that's what we're expanding. We're expanding the binomial to the 4th power. Why did I start with an a? Because our first term here is an a. I could have just as well started with the h. Because this is symmetrical, it would have ended up being the same. Go ahead and try that a few times and you'll see that you get the same thing either way. And now let's expand to the h. So I could start at the beginning and then use a 0, or I could start at the end and start with h4. I'll go ahead and do h to the 0, h to the 1, h squared, h cubed, and I'm going to end with h4. Now all that's left is simplifying. So I have a to the 4 plus 4a cubed h plus 6a squared h squared plus 4a h cubed plus 1 times h to the 4, and that's it. You could do this by multiplying it out, a plus h times a plus h times a plus h times a plus h, but I think that using this pattern is much easier. While you're here on this video, I thought I'd just give you a free 3-minute bonus. If you haven't caught this yet in our course, these are all items, these are all pieces you need to have memorized. If we're factoring a binomial, if you factor a plus b times a minus b, when we have a squared minus b squared. So a squared minus b squared is equivalent to a plus b times a minus b, because it's the difference of two squares. A difference of two cubes, which we often need to factor, starts with an a minus b, and then it's a squared plus ab plus b squared. Now, you may have remembered this in the past by using an acronym SOAP. The first sign is the same as the sum or the difference. Since this is a difference, we start with a difference, so the same. And then this next sign is going to be the opposite of this. So since this first one was a subtract, the second one will be add. And then always positive. Spells SOAP. Same, opposite, always positive. So you may have memorized this pattern using that acronym, that mnemonic rather. And then for a cubed plus b cubed, similar to what we have above, but now we're going to have the same sign as positive. The second sign, the opposite, is negative. Please make note that the coefficient of this second term is a 1. It's not a 2 like we get over here when we multiply a plus b times a plus b. It's a squared plus 2ab plus b squared. So don't let this factoring pattern and this multiplying pattern get confused between the two. Here, if we have an a minus b and expand it, you could use the pattern we did in the previous page. Use Pascal's triangle to get this. But when you do use Pascal's triangle, you're going to get a squared minus 2ab plus b squared. And then a plus b times a minus b, there's our difference of squares. Again, a squared minus b squared. Well, I hope that this short video has helped you just refresh some of the algebra that you may have either missed or forgotten. And these pieces in algebra will help you with the work we're doing in calculus.